Okay, Matteo, what have we got now?
Well, this is a tower crane,
Okay,
as you can see. Right here's the tower. It can swivel. Over here's the jib, which is just another word for boom. It's just what we call the boom on a tower crane, the jib.
okay,
And here we have a little bit of counterweight. And then the load, of course.
all right. Well, when you're lifting the load, you're using the windlass?
Yep. I'm sure you can hear that clacking.
Keep going, doing the... Okay, good. And we've got two lines holding up the load, so that gives us mechanical advantage
Two.
of two. Okay,
We'll
so,
get to that later.
good. So let's put on the double brick load, which is, I get bricks from any Home Depot. Lumberyard will have bricks. They're usually about 4.7 pounds. And we got two of them, so the load is 9.4 pounds.
Right. All good.
Okay, now we've got, so 9.4 pounds for the load. The counterweight is one brick. That's 4.7 pounds. So yeah, lift up the load a bit.
Gotta be careful with it.
Okay. Yeah. Good. Now, make believe we're on a job site and the foreman says you've got to place the load pretty much where your hand is,
Right here.
someplace like that.
Yep.
A little further away, but, so we have to swivel or slew the crane 90 degrees.
Well, let's see what happens. Oh, it's starting to tip. Well, that's odd. We didn't really change anything, did we?
Well, the load is still the same,
It's nowhere different on the jib. It's same place on the jib.
so what changed?
Well, if you're observant, you may have noticed these little outcrops of wood. Right here is called the
Outriggers, yes.
outriggers. They're
Okay.
just to make sure the entire thing's level.
So actually, okay, you can't see the level, but that's what we use to make sure the crane is level. So when you turn that bolt, that'll raise or lower each corner of the crane. Okay.
You can adjust each one, make sure the entire thing's level.
Okay. So, well now, where's the pivot point on the crane right now? If you tip the crane over,
Well, right now, if I were to tip it over, it'd be on the two front outriggers.
good. That's right. Okay.
You can see they're pushed out more. And then if I turn it, which I'm not going to do because it'll tip over again, it's these two outriggers. And if
Oh.
you'll notice, right here,
Well, let's run the numbers first.
Yeah.
So bring up the, yeah, there we go.
so, as I was saying, when it's turned like this,
Yes.
the distance between the center of gravity of the boom, or the jib, to the pivot point, right here,
Good.
is 8 inches.
And what about to the center for the load?
For the load, over here, it's 20 inches.
So let's see, when we do the torque is weight times distance, right?
Yep.
So let's see the numbers there.
So for the right side,
Yes,
the load is 9.4 pounds, 2 bricks.
good.
20 inches away, times those together, 188 inch-pounds of torque. For the boom, we just do 2 pounds times 8 inches, gets us 16 inch-pounds.
Okay, and total?
204 inch-pounds of torque.
Okay, now let's look at the other side.
With the tower, we take the center of gravity of the tower to the pivot point. That's 10 inches.
And for the counterweight?
For the counterweight, it's 18 inches away, and it's 4.7 pounds.
Okay, so let me see the numbers now.
Yep.
That other poster.
So
Okay.
for the tower, 22.8 pounds, 10 inches away. Multiply those together, we get 228 inch-pounds of torque.
Good.
For the counterweight, it's 4.7 pounds, 18 inches away. That gets us 84.6 inch-pounds of torque. Add those together, we get 312.6 inch-pounds of torque, which is greater than the 204 we have on this side. So right here, it's fine. It doesn't tip over.
Okay, but
But when we turn it, the only
Okay,
thing that
so-
ends up
so-
changing.
Well, I tell you what, unhook the load and turn it so we can
Yep.
see what's going to happen.
Right.
Okay, so now when we measure from, let's say, the center of gravity of the tower. Well, here, let's look at the crane first.
Yeah.
So show me where so the center of gravity of the tower is,
Same place.
well, do it in front so we can see.
Yeah.
No, come in front here.
What do you mean? I'm sorry.
Oh, that's all right. So well, just point from the center of gravity, here, come on this side.
So.
Yeah, there we go. Center of gravity of the tower
Right
is
here.
down there. And from there to the pivot point is less than it was before.
Yep. We
And
don't have these pieces of wood pushing out the pivot point so much.
Exactly. So it's a shorter distance. Now what about for the distance from the center of gravity of the load to the pivot point? Is that more or less?
Now it's more. So from here to the pivot point, that's a greater distance than it was over here.
Good. So let's see the second poster.
Yep.
We can see that a little better.
Here's with it how it is now.
Okay, so before it was 20 inches from the CG of the load to the pivot was 20 inches, now it's 24. And what about the CG of the boom?
Now it's 12 inches away, which is further than it was before.
Right, it was 8, now it's 12.
Yep.
Okay, and on the other side?
Now the stuff on the left side, or the tower side, is less. What was, I believe, 8 inches
Yes,
is now 7 inches away. And
Okay.
13 inches
instead of 18.
instead of 18. So, if we run the numbers again,
Good.
for the load and the boom, or the jib, we take the 2 bricks, 9.4 pounds, times it by 24 inches away, right here.
Good.
We get 225.6 inch-pounds of torque, plus the 2 pounds times 12 inches away
For the boom.
for the boom, 24 inch-pounds of torque. We get 249.6 inch-pounds of torque on
So-
the boom side of the.
On the boom side, so the torque went from 204 to 249.
Yep, you can see the difference.
Good, okay. And on the
Now-
other side?
For the tower, we do the same thing, except now it's 7 inches, same weight, 22.8 pounds times 7 inches gets us 160 inch-pounds of torque. We take the counterweight, 4.7 pounds, times it by its new distance of 13 inches, we get 61 inch-pounds of torque. Add those together, we get 221 inch-pounds of torque, which is less than 249 we have on the boom.
So,
It tips over.
simple math, okay.
So if you notice, the torque for the tower decreased while the torque for the boom increased.
But hold it there a second. Okay, so 249 instead of 204. And
221.
221 instead of 312. And all it did was swivel or slew the crane.
Yep.
And usually with smaller cranes, when the whole crane pivots or slews, that's when it's in danger of tipping over.
Mm-hmm.
Good.